Today we have something quite special. My shoulder unit stopped working. And I thought it was my batteries were dead, but they were not. Let me show you guys what it's doing, and then we're gonna troubleshoot this together. So these batteries have just been fully recharged. They're good to go according to the charger. I did not test them. Alright. So what's happening is when I turn it on, it goes on and it stays on. Or maybe my batteries are not fully charged. Well, it looks like this is going to be a really quick video. Well, video done. It's complete. It's working just fine. My batteries are not fully charged, I guess. Well, that is a good news, because that way at least I know the system works. I've been using this thing like crazy, non-stop. It's been doing wonderful for my shoulder. So as you can see, I don't know if you can see the wear and tear on this, like from rubbing. It's crazy. I've been using it like mad, and it's working its magic, let me tell you. Okay, well, since the video is now complete, let's move on to the next thing. Oh, by the way, this is my stripping tools, different size, from smaller wire, bigger wire, that I've been using all my life as a professional electrician in the oil field and stuff like that. This has been my tool. I've seen a lot of guys using the automatic stripper, and I never liked them. I always thought they were gimmicks, and most of them were gimmicks, even the good Klein tools one. But Klein just came out with this thing, and I'm not one to promote tools or nothing like that, but let me tell you, if you strip a lot of wire, this freaking thing, I still don't understand how it works. Like, I know you think it's simple, but what it does is really weird. Watch this. So I got an extension cord here. I put that in, and it strips the outside without any adjustment or nothing. Okay, I'm gonna strip it again. Just strip the outside, and then the same swoop will strip the inside. It doesn't touch the wire. Like, it's just like a feat of engineering. This is what this thing is. If it fits in there, you can strip it. Anyway, I'm gonna stop the video, and I'm gonna clean up this mess, and I'm gonna get ready for the next thing that I wanna discuss with you guys. Stand by. Hello, welcome to this week's video. This video was originally intended to go on my Patreon site, and it was about fixing my shoulder, which you saw in that first part there. Looked like it's working. Stand by, it's not. So we're gonna troubleshoot it next. The reason why I'm posting this video at the beginning of the year, not my super duper video that I've been working on for months now, is basically because I got to make sure what I'm about to say in that video is true. I asked some pretty good mathematician, like physicist people, electronics engineers and physics engineer to basically check my claim, and they're struggling with some of the math I do in there too, because it's so weird. It's just not math we do every day, right? So anyway, long story short, the video is coming together. I have right now an hour-and-a-half long video on that, and it's going to touch on what is PEMF, how does PEMF work, how to build a good PEMF system, high voltage versus low voltage, or high gauze versus low gauze, and a bunch more. The math behind my mat. So this one is going to be a doozy. But anyway, long story short, like I said, it's going to upset a lot of people, but it's going to be a good one. So stand by, it's coming, it's coming. Anyway, let's get back on to fixing my shoulder PEMF right now. Okay, so turns out that this is not working. So now we're going to troubleshoot it up. So I had it on for a little bit and then it shut off again. So I checked the battery. The battery have the voltage, and there you go. You just so I don't know if you're seeing what I'm seeing. Let's make sure you're seeing it. There we go. Okay, so I turn it on, it goes off. It's on. It was never used to flash red. See, it's off. On, off. So I don't know if the button is what's dead or the PWM is dead. I think the PWM is dead. I mean the button. I am pretty convinced that the button is my issue. So basically here, all I'm doing is explaining, because remember this video was designed for the Patreon originally. So I was making a long video explaining how I troubleshoot stuff. I mean, I have quite a bit of experience troubleshooting things, right? And when we fall into a new categories of something that we've never encountered, like a problem we've never encountered before, it's really important to start somewhere. Now, in this one, the button was the cause of the malfunction. The button was possessed, basically. But why? This is what's really important, so we don't repeat the mistake. You know, we have to find out why the button failed. Is it because it was a manufacturer defect? So if we cannot rule that out, then we install a new button and we see if the next one does the same thing. Then we have to review our mat. We have to review what's happening and this and that. And then we're going to talk about that in a second here. But you'll see that the biggest issue in that, right, is not that the button failed, is the reason why it failed, so we can fix it long term. Alright, so let's move on to... Okay, so I want to measure the voltage when the batteries are fully charged and ready to go. So 8.3 volt is what we get. The resistance is 2.6. So let's just go make a 2.6 resistance right there. So right now we got 1.79. So if we increase the coil diameter, let's increase the wrap. 2.6, we're almost there. 130, 125, there you go, 2.62. Okay, the batteries are 3500 mil and they're in series, so 3.5 is what the max they're gonna give, right? Okay, so what's happening right now is when the lithium batteries are fully charged, we're looking at 3.16 amp. And guess what? I went to the website. Let's bring it over here. Here's our button. It's not the one that I ordered. I cannot find the one that I ordered exactly, but the first spec I found was a max of 3 amp. We're going to go ahead and assume they're pretty much all the same. Let's check this one. So this one has 4 wires just like the one that I bought. And the specification of this one doesn't tell us the number of amps that it can. So let's look for another one. Let's say this one. You think they'd be pretty much doing all the same. This one is also 3 amps. So and this one has 4 wires like the one that I am using. And it's got the colors. So I think the big issue is that when the lithium batteries are fully charged, we are slightly overkilling our system, our switch anyway. So I don't know exactly how we could tweak that down just a tad, but anyway, found the problem. I think we're slightly above spec. Because if we look at this, that we want to be at 3 amp is the max that we can give, we're pumping 105.456%. So we're over by 5%, 5.5%. So we're overdriving our switch. We'll have to fix that. It's a good switch. We just cannot have it doing this. Here's what I decided to do. I was going to use an L7808 IC chip, their voltage regulator. The problem with those is they fluctuate between 8 and 8.3, which would not help us at all. Not only that, they need 7.8, I think, minimum voltage to actually output the 8 volt, because they're designed to be driven by 24 volts or 24 to 30 volts, and they'll bring it down to 8. So that won't work for us. A buck converter won't work either. Too big, too clunky, sucks too much power. So what I decided to do is use a typical, very simple voltage divider that we do in electronic. But to measure the 2 resistors we're going to need, you need to find out the percentage, the ratio of your resistor up and down. So we want the output to be 8 volts. And we know the input is 8.3, and then I guessed at 4%, so it's 8.32. So 4% is basically what we want. So here's a voltage regulator, and here's the way it works. So I got 8.3, and I need 4%. This is it right there. So basically 8.3 from a brand new battery will go. And we're going to lose 4% here, which was going to give us 8 VDC right here. You can do 2, 20, 50, 1, 25 ohms. As long as you're a ratio of 4%, right, 1 to 25, you can do any combination of that, it'll go. If you keep the resistance small like this, there shouldn't be no heat whatsoever in there. I got a resistor kit right here, and I'll just try it out and see how it goes. I probably don't have anything that small, so I may have to jimmy rig something. I may have 40 ohms, might be the smallest one I got. Anyway, I'll check it out. But that's the way I decided I was going to do this. I'm going to use a voltage divider, and yeah. And then right here, we should have what we want, as long as I got my ratio. And that should be really small, really compact. I should be able to hide that inside the box, and it should control my my amperage, so that way we don't fry the button. Talk to you guys soon.